When people imagine the future of artificial intelligence, they picture bigger data centers, more GPUs, more racks, more land. But what if the real limit to AI isn't chips, or algorithms, or even money? What if the real limit is Earth itself? Right now, AI data centers are running into the walls that no software can fix. Electricity shortages, water scarcity, land constraints, and political resistance. And as those limits tighten, a radical idea is quietly moving from science fiction into the serious engineering. Putting AI data centers in space. Not satellites that just rely signals, but real compute, real chips, and real workloads, operating beyond the physical limits of the planet. This isn't about escaping the Earth. It's about keeping AI growing when Earth can't keep up. Hello and welcome back to Chips Weekly by Diana. I'm Diana and today we are exploring one of the most unconventional and yet increasingly realistic ideas in modern technologies: AI in space. As artificial intelligence scales, it's no longer limited by how fast the chips can improve. Instead, it's limited by where those chips can exist. How much power can they draw? How much heat can they shed? And how much water and land they consume. This episode is about why Earth is becoming the bottleneck for AI. What kind of chips space-based compute would actually require? Which organizations are already experimenting with this idea? And whether orbital AI is the future or simply a pressure valve for a saturated planet. Let's start with a constraint nobody likes to admit. AI consumes electricity at a scale most people underestimate. A single modern AI data center can draw between 100 and 300 megawatts of power, roughly the electricity demand of a medium-sized city. According to the International Energy Agency, global data center electricity consumption could double by the end of this decade, driven primarily by AI workloads. Cooling is just as demanding. Large facilities consume millions of liters of water per day to manage heat, and in many regions, water rights are now the political issue. Grid expansion is slow. Permitting takes years. Communities are pushing back against new facilities. This means AI growth is no longer limited by how many accelerator companies like NVIDIA can ship. It's limited by whether there is something left to plug them in. Space offers something Earth increasingly cannot: freedom from terrestrial constraints. In orbit, solar power is continuous. There is no night cycle, no weather disruption, and no competition for land. Cooling works differently as well. Instead of water-intensive chillers, heat can be radiated directly into the vacuum of the space. There is also a strategic element. Orbital infrastructure doesn't require zoning approval, doesn't depend on national grids, and isn't exposed to local political resistance in the same way ground facilities are. That's why agencies and startups are revisiting an old concept with a new economics: orbital computing platforms, not to replace Earth-based data centers, but to extend capacity when Earth becomes saturated. Here's a key insight most discussions miss. Space-based AI doesn't use the same chips as terrestrial hyperscale data centers. Data center accelerators are designed for brute force throughput. They assume massive power budgets, dense cooling, frequent maintenance, and physical access. None of those assumptions hold in orbit. Space chips must prioritize energy efficiency over peak performance. They must operate autonomously for years. They must tolerate radiation, and they must manage power at the extreme level of precision. That pushes space AI toward highly integrated, system-on-chip, specialized accelerators, and conservative operating envelopes. Think less GPU cluster and more self-contained supercomputer. On Earth, chip designers worry about heat and yield. In space, the enemy is radiation. Cosmic rays and solar particles can flip bits, corrupt memory, and physically degrade transistors. That's why space-grade electronics traditionally lag commercial chips by several generations, often using older nodes, like 28 nanometers, for reliability. But AI changes the equation. AI systems can tolerate redundancy. They can correct errors at the model level. Distributed inference and fault-tolerant architecture allow newer chips to survive environments that traditional space electronics never could. This opens the door to a new class of hardware, not cutting-edge nodes, but resilient, AI-optimized silicon designed specifically for orbital conditions. For decades, this idea failed for one reason: launch cost. Before reusable rockets, sending hardware to orbit cost well over $20,000 per kilo. That made any large-scale compute infrastructure economically impossible. Today, launch costs have dropped by roughly an order of magnitude, driven by reusable launch systems, heavy payloads, modular platforms, and regular deployment cycles are now realistic. Space is still expensive, but it's no longer unreachable, and that changes the calculation. This isn't theoretical anymore. Defense agencies are testing in-orbit processing to reduce data downlink bottlenecks. Satellite manufacturers are embedding AI accelerators directly into the payloads. Startups in the US and Europe are experimenting with orbital compute modules for inference and analytics. No one is building a hyperscale space data center yet, but the architecture, the chips, and the economics are being validated right now. AI in space isn't just about performance, it's about control. Orbital compute bypasses national grids, reduces dependence on terrestrial infrastructure, and offers resilience against physical disruption. That matters for defense, climate modeling, global communications, and sovereign AI capability. Space won't replace Earth, but it may become the ultimate overflow layer when Earth says no more. Here's the real takeaway. AI isn't just pushing the limits of silicon, it's pushing the limits of the planet when power, water, land, and politics, they become the constraints. The innovation doesn't stop. It moves, sometimes off the planet. So let me ask you, do you see AI in space as a breakthrough or as a warning that Earth is already reaching its limits? Let me know in the comments. And if you enjoyed the special edition, like, subscribe, and share it with your network. And as always, stay curious, stay sharp, and stay chip aware.